Here we go. Yeah, so my intention was to generate an NFT collection using GANs on this artist that I like, Camelia Otero. I'm supposed to be an urban scientist, but to be honest, that was so fun to play with the GANs that I'm thinking of changing my career. No, okay. So that's Camelia here. You can see her trying to hold her family on her shoulder. This is her son Armani in the middle, my friend, and the grandson on the top of his head. He's the son of her daughter. And so I like what she's doing. She has been painting for years without any visibility, I would say, but I guess something like 10 years ago she started to become very popular and to be invited in a lot of events in Venice, in everywhere actually. So I'm really happy for her, and she's doing different kind of artwork. You can see some has very flashy colors, some other ones are more neutral. She both does actual painting, and some are figurative, some are more abstract like the blue one. But she also does the same with digital art, so some of them are made on an iPad, I believe. And so yeah, she's part of this movement that's called art brut in French. It means outsider art. So let's say she believes that it's a sort of, maybe not revenge, but yeah, a takeover of spontaneous artists, those people who hasn't been maybe in an art school or are not engaged or paid by some academy, but just yeah, express themselves in painting or whatever other form of art. And yeah, that's it. Actually, I've been collecting the data on her Instagram with her authorization, of course. So I've been scraping. I built a scraper using Selenium to collect all the images on her Instagram accounts. And at the end, I had a data set with 1,400 pictures of different size. Some of them are not so well framed, so I've been filtering that to have 1,000 images of the, let's say, best quality with no background and nothing. And so I first started this GAN. The first one was my baseline, I would say. It's a simple GAN using convolutional 2D layers with a leaky ReLU for both generator and discriminator, and actually on using that on 28 times 28 pixel pictures for 50 epoch. And actually I was very happy with these early results. It sounded like, yeah, it looked like it was really doable. And so of course it's not the same style of painting, but I really appreciate the kind of, yeah, computational interpretation, abstraction of some painting using the colors. So that was really cool on the beginning. You can see the loss, the model is learning, right? So it was really encouraging. And then I've been trying lots of different more complex models, which you will see didn't work for different reasons. That's the first one I tried, DC-GAN. So it's adding batch normalization for the generator and dropout for the discriminator on the conv2D and leaky ReLU layers. The first one, 28 times 28, didn't look so bad, but actually I was a bit annoyed by the fact that you have to choose the color that you want. So the model is only generating black, gray or black and white pixels, and then you are choosing the color map that you want, and then it is recoloring the images. So here, yeah, okay, the first one, again 28 times 28, you can see, okay, it's not bad, why not? But no, actually the model is not working. You see that when I started with bigger pictures, 64 times 64, 50 epoch with this other map of color that's called cool. And so I tried with the GIF to visualize the history, and you can see that the model is not learning nothing, right? And so then I was like, okay, maybe you need more epoch and you need a more diverse color map so it can reproduce something, but no, actually it's not reproducing nothing. You can see that on the third trial, and so from what I can diagnose, I think that there is this problem that we call the convergence failure. The model doesn't manage to converge in something that's interesting, so it doesn't learn nothing. So after that, I've been trying the GAN. I told you that last week, but it always crashed. So the GAN is built with bigger pictures, 256 times 256. I've tried to adapt it to smaller pictures, but I couldn't do that. I'm assuming the GAN is a model that is used to generate high quality fake pictures of landscapes, usually from drafts. And so, yeah, it's usually generating high, beautiful pictures like 1024 pixels time something like that. So I tried that on the Colab. It was not working. It was crashing. I tried that on the Jupyter notebook in local. I think my computation's not very powerful here, but still, so it didn't work. So I didn't want it to stop here. I tried another one, the GAN, which I'm not detailing the architecture here. We saw that in class, but I like the GAN implementation that I found, which is having a convenient progressive growing. So it starts at 4 times 4 pixel and it goes to 128 to 128. So that looked funny, but yeah, we can see from the results we are still very far from the original. It's not drawing any painting. I don't know if it's acceptable as an art piece. I'm not an expert, but so you can see the results on the bottom right. And yeah, this is not what I was trying to do, even if it's full of colors and maybe, yeah, funny. So I tried another DC-GAN. That was my last try to make something more advanced. And here again, I guess I lack of computation power locally, but also on the, so we'll detail that. So I started with 128 times 128. So you see the kind of image that are being used as an input. I have 3 of them here, and the runtime is disconnected after 20 epoch, which is usually about 10 or 12 hours actually, so it's very long. But yeah, the Colab doesn't do much work than some amount of hours. I would say about 10 hours it's stopping. And so I said, okay, that's very encouraging. You can see that the 2 curves are slightly going together. So yeah, maybe you should reduce your image size and do it again. And so I did it at 64 times 64. And you can see that, yeah, it's taking less time. It's crossing, I mean, it's learning more easily, so you can see the cross between discriminator and generator arrives early. And then you also, I mean, I'm imagining that the curve is starting to flatten. So at the end of the run, the generator looks like it's starting to flat, like stop increasing. So I was like, okay, it's crashing again. Let's try another time with even smaller pictures. And so I chose 28 times 28 pixels. You can see that the quality is really lower as an input. But same, I had this, I mean, the duration is very long. You can see for one epoch, it's taking almost 2000 seconds. I haven't converted that in minutes, but I realized that you may work with 128 or with 28 pixels images, and it's quite very long for all of it. So I don't know, it crashed after 12 epochs, and so I cannot avoid this runtime disconnection. So that's a bit sad. My conclusion on all that is that, well, I've had some promising results with the baseline model and also with the other models, because the code runs and it shows some learning signs. I would need more computational resource to be able to run the more advanced model. I guess that's what I lack, because okay, Colab maybe doesn't allow so much work online, but with one more powerful local computer I can probably do it, I guess. And otherwise, I've seen there are some tricks on internet to avoid the runtime disconnecting. You have to do some manipulation, and then your Google Colab doesn't kick you out anymore. I haven't tried that, honestly. I didn't have time. I saw that this morning. So, but that's it, actually.
Yeah, thank you really much. So like